To add or subtract two fractions, we put both fractions on a common denominator. The easiest common denominator to work with is the least common multiple of the denominators. We may have to use prime factorizations to find this least common multiple. Let's illustrate this with the example on page 45. Simplify 7 over 60 minus 1 over 18. Note that 60 is 2 squared times 3 times 5, and 18 is 2 times 3 squared. So the least common multiple of 60 and 18 is 2 squared times 3 squared times 5, which is 180, our common denominator. So we get 7 over 60 minus 1 over 18 is, we need to put this on common denominator 180. So how can I put the denominator 60 on 180? Well, 180 divided by 60 is 3. So we will multiply numerator and denominator by 3. To change the fraction 1 over 18 to denominator 180, notice that 180 over 18 is 10. So we will multiply numerator and denominator by 10. We simplify. Now that we have a common denominator, we can just subtract the numerators. We simplify and find 11 over 180. The same ideas apply to adding or subtracting rational expressions. So here's a basic strategy. Factor the denominators completely. Find the least common multiple of the denominators. Put all rational expressions on a common denominator, which we found in step 2. Add or subtract the new numerators, and simplify the result. Let's illustrate this with the examples on page 45. Question 1. Simplify 11 over 8x plus 7 over 18x squared. We start by factoring the denominators. 8x is 2 cubed times x, and 18x squared is 2 times 3 squared times x squared. So we see that the least common multiple of 8x and 18x squared is 2 cubed times 3 squared times x squared, which is 72x squared. Next, we put all rational expressions on the common denominator 72x squared, add, and simplify if possible. So 11 over 8x plus 7 over 18x squared is equal to. We need to change the denominator 8x into 72x squared. Since 72x squared divided by 8x squared is 9x, we multiply numerator and denominator by 9x. For the second fraction, we need to put that on common denominator 72x squared. Since 72x squared over 18x squared is 4, we multiply numerator and denominator by 4. We work this out, and we get 99x over 72x squared plus 28 over 72x squared. Since we have the same denominator, we can just add the numerators. And this is our final answer. Example 2. Simplify the following subtraction. We start by factoring the denominators. For x squared minus x minus 6, our method says that we are looking for two numbers whose sum is negative 1 and whose product is negative 6. We see that negative 3 and 2 work. Negative 3 plus 2 is negative 1, and negative 3 times 2 is negative 6. So we can immediately factor as x minus 3 times x plus 2. For x squared plus 2x, we can factor out the greatest common factor of all terms, which is x, and once we factor out x, we are left with x plus 2. Our denominators are x minus 3 times x plus 2 and x times x plus 2, so we see that the least common multiple of the denominators is x minus 3 times x plus 2 times x. Next, we put all rational expressions on this common denominator, subtract, and simplify if possible. we need to be very careful to use parentheses, foiling the product of two binomials, and to distribute a minus sign. So first, we replace the denominators by their factored version. Next, we put both denominators on common denominator, x minus 3 times x plus 2 times x. For the first fraction, we need to multiply numerator and denominator by x. For the second fraction, we need to multiply numerator and denominator by x minus 3. Since we have the same denominator, now we can just subtract the numerators. Next, we have to FOIL. X minus 1 times x becomes x squared minus x. X plus 1 times x minus 3 becomes x squared minus 3x plus x minus 3. Be very careful to use parentheses around this last group of terms, since we must be subtracting the whole quantity x plus 1 times x minus 3. Next, we distribute the minus sign. And finally, we combine alike terms to simplify. And this is our final answer. Question 3. Simplify the following subtraction. We start by factoring the denominators. For x squared minus 9, notice that this is a difference of squares. So we rewrite it as x squared minus 3 squared and then use our formula. For x squared plus 6x plus 9, our method says that we are looking for two numbers whose sum is 6 and whose product is 9. We see that 3 and 3 will work. 3 plus 3 is 6, and 3 times 3 is 9. So we immediately have the factorization x plus 3 times x plus 3, which we can simplify to x plus 3 squared. So our denominators are x minus 3 times x plus 3 and x plus 3 squared. We see that the least common multiple of the denominators is x minus 3 times x plus 3 squared. Next, we put all rational expressions on this common denominator, subtract and simplify. So first, we replace the denominators by their factored version. Now we put both fractions on common denominator x minus 3 times x plus 3 squared. For the first fraction, we need to multiply numerator and denominator by x plus 3. For the second fraction, we multiply numerator and denominator by x minus 3. Since we have the same denominator, we can just subtract the numerators. Next, we distribute the minus sign. And finally, we combine alike terms. Now this answer can be slightly simplified since we can still factor the numerator. We factor out the greatest common factor of the numerator. We have 2x and 36. The greatest common factor is 2. And when we factor out 2, we are left with x plus 18. And here is our final answer.